Hey AP Chem students, welcome back. This should be a fairly short video, and we've already seen hopefully some of this before, so hopefully it'll be review for us. In AP Chemistry, and actually all chemistries, they want you to be able to represent what it would look like on a microscopic level, and those are called particulate diagrams. All right, so a particulate diagram would be, it shows basically the atomic level. All right, so we could see the atoms and so on. All right, so let's just kind of do some simple ones to start off with, and then your homework takes you a little bit further, but for right now, let's see what we got. So a solid, remember our definition of a solid is one that keeps the shape, right? It doesn't take the shape of a container. So here's my container. That green box is a container. So to represent a solid, we're going to draw something that keeps its shape. So if I just choose like some circles here, that would be representative of an element, an elemental solid actually, in fact, right? Because they're all the same shape and they're taking the shape, or they're keeping their own shape. All right, so let's change gears just a little bit and let's go to a liquid. Remember, a liquid takes the shape of a container, and this time let's draw a compound. So a compound is one that is the same throughout, right? But it's more than one element. So let's go with a circle. And remember, it's taking the shape of a container. So let's go a circle and a triangle as our compound all the way through. All right, that last one looks a little rough because it's not real near the circle. So let's change that. But yeah, this one's taking the shape of a container. They're kind of a little more spread out. And it's a compound because it's the same ratio of elements to each one. Now for a gas, remember it takes the shape of the container, and the volume is also variable, which means it takes the shape of a container. And this time let's do a mixture, and it can just be a mixture of any type of gas. So let's do some circles here. All right, and then what about some squares maybe? All right. And this would be a mixture of a gas, right? Because it's not the same throughout. It's kind of just all mixed up. Okay, so that's kind of the simple or the preview part. Let's move to a reaction and kind of what they want us to be able to do with a reaction. So here's what we've got. Aqueous sodium chloride reacts with aqueous lead-2 nitrate to form solid lead-2 chloride and aqueous sodium nitrate. Woo! Okay, so that's kind of a lot going on. So we need kind of 4 basic shapes. So let's go with our first shape for sodium. Let's go a pink circle, all right? So for sodium, we're going to go this pink circle. So for sodium chloride, it's aqueous, right? So I always like to draw like kind of a little bit of solution in there so I know, right? That's my water level, all right? But again, it's on the atomic level, so you wouldn't have to draw this, but I just like to draw it because my OCD thinks I need to do that. So sodium chloride, when it's in there, when sodium chloride goes into solution, it breaks into its ions, if you remember, right? So I'm going to draw like 2 circles, okay? And that will represent my sodiums. And if we look at our formula for sodium chloride, it's NaCl. So if I have 2 sodiums, I need 2 chlorines. So let's make chlorine this purple thing, and let's make it some squares. So if I have 2 circles, I need 2 squares. So my chloride is going to be that square. All right, hopefully we're all with me so far. Now let's move to lead nitrate. Lead, let's represent that with green, and let's go a triangle for our lead here. All right, and so lead nitrate, real quickly, just to review, is Pb parentheses NO3 parentheses 2. So for every Pb I have, I need 2 nitrates. And to keep this from getting too crazy, I'm just going to put 1 triangle in there. And again, since it's aqueous, that means it breaks into ions, so it's going to be separated from my nitrate. My nitrate, we're going to have to pick something else out, so let's go like a black dot. That could work for us, right? Okay. So my nitrate is going to be represented. My dot maybe should be a little bit bigger. Let's try that size. Oh man, that's going to erase like all sorts of everything. Let's try here. Okay. So our black dot, there's our nitrate. And so our nitrate is this dot here. Okay? So keep it rolling. Now, oh, but I need 2 of those. Thank you. Good save. So I've got those 2 nitrates for every lead, right? We also need to keep them in terms of sizes as well as their stoichiometric relationships, but we really haven't talked about stoich yet. So we'll also revisit this later. But now we go to, we're going to form solid lead chloride. Solid lead chloride means it's going to stay together. And kind of as a real quick aside, lead chloride is going to be PbCl2, so for every triangle I'm going to have 2 boxes. So our triangle was green, so we've got, and remember it doesn't take the shape of a container, so it's going to stay there on the bottom, kind of rigid. And how about that? That would be our solid lead chloride, and we've got 2 chlorides for every lead. And then for our sodium nitrate, we need a pink one, and we need a black dot. But we need the dot to be a little bit bigger. I think this is what we went with. And there we go. So there we have kind of a particulate diagram for that reaction. And we'll get more practice with that, like I said, in stoichiometry. But hopefully this will help us for where we're at right now. Awesome. See you next time.